Hello students. Hello, welcome in our channel class 10 NCERT SSC Math with Sujata ji. Now students, let us see the part 2 and part 2 for the class 10 SSC previous year board question paper Maths 2 July 2023. Okay students, it is the part 2 for July 2023 previous year board question paper. So now let us start the remaining part of this July 2023 board question paper. Okay students, so here the question is for I think question 2b. Okay, question 2b, the third one question students. Okay, and no, here students, this is a fourth one question. Okay, fourth one question. So in the above figure, angle MNP is equal to 90 degree. Segment NQ perpendicular segment MP, MQ is equal to 9, QP is equal to 4 and find NQ. Okay students, so now here first we write down the given. First we write down here given. So given is that in triangle PNN, angle MNP is equal to 90 degree, segment NQ perpendicular segment MP, NQ is equal to 9, then QP is equal to 4, QP is equal to 4 and NQ is equal to question mark. Okay, we have to find out the value of NQ. Okay students, so see here in this question, in this figure, that which one is the NQ. So this segment is the NQ and that we have to find out. Okay, and that NQ is the perpendicular on the hypotenuse students, on the hypotenuse, and that's why here we use the theorem of geometric mean. Okay, we use the theorem of geometric mean here. Okay, so now here I write first by using theorem of geometric mean. Geometric mean. So what that formula? We get a formula NQ square is equal to QM multiply QP. So here NQ that we have to find, so write as it is square of NQ, QM that is N multiply QP and that is 4. So 9 4s are 36. So NQ square is equal to 36 and Q is equal to NQ square is equal to 6 square. So square root on both the sides. So we get students NQ is equal to 6. NQ is equal to 6 students. Okay, so by using the property of geometric mean, we can solve it. And there is a clue students that there is a right angle triangle. In that right angle triangle, there is a altitude and that altitude is on the hypotenuse. Then we can use theorem of geometric mean. Okay student, so this is the clue students that you have to get from this example. So now here let us see the next one example students. So the next one example, fifth one, that in the above figure, if AB parallel CD parallel EF, then find X and AE by using the information given in the figure. Okay students, so by using the information as per the figure, we can say that there are the three parallel lines. And of course we can say that these BD, BF and AE are the transversal. So here we can use the property of three parallel lines and their two transversal. Okay, student. But before writing that, first we write down the given. Okay, students. So here first write down the given, and that given is that AB parallel CD parallel EF, and we have to find x is equal to question mark, and here students AE is equal to question mark, and the given is that as per the info, as per the figure students, here CBD is equal to 8, DF is equal to 4, AC is equal to 12. Okay, student, this way, and CE, that CE is equal to X, which is question mark, that we have to find out, student. So I write here, students, that by using three parallel lines, three parallel, by using property of, by using property of three parallel lines and their two transversals. There are two transversal. Okay, so the ratios are equal. Okay, the ratios on the first transversal is equal to the ratio on the second transversal. So the ratios becomes BD upon DF is equal to AC upon CE. So now here BD, that is 8 upon 4 is equal to 12 upon x. So now here cross multiply here, students. X is equal to, here we can 8 into x, 4 into 12. So here students, that x is equal to 4 multiply 12 divided by 3. Sorry, divided by 8. That is 8. Okay, so here 4 ones are 4, 4 twos are 8, then 4 2 ones are, and 2 6 are. So x is equal to 6. Okay, students, the x is equal to 6. That means here, students, CE is equal to 6. Therefore, CE is equal to 6. Now here, students, as well as we have to find out the AE. See here AE. How the AE form? The AE form as the addition of AC and CE. Addition of AC and CE. And we know that AC has 12 and CE has 6. So here AE is equal to 18. AE is equal to 18. Okay, student? So there's such a way we can, by using the property of three parallel lines and their transversal, we can calculate the CE and as well as AE, students. Okay, students? Very, very easy example, students. Okay. Now here, students, the next one example here. See the next one example. It's from the question 3, students. It's from the question 3. A. Complete the following activities and rewrite it any one. So now here we know that, students, that question 3A is based on the activity. Okay, activity based question, and that was very, very easy question. There are the 6 boxes and we have to fill up that all the boxes, because each box having the half marks. And so students, we have to properly fill up the box. Okay, then we can get the 3 marks. Okay, so let us see the first example. Now here, students, the activity is that, see here, in the above figure, x is any point in the interior of a triangle. Okay, see, this is a triangle. DEF is a triangle, and here, students, see, this one is the x point and x is the interior point in the triangle DEF, and point x is joined to vertices of triangle segment PQ. Okay, and then see here, the x, this point x connected with or joined to the vertices, okay, of the triangle. See that triangle, this joint dx, here xe, here xf, okay students, and as well as they give us that segment pq, see here, segment pq parallel de, segment pq parallel de, segment qr, see here students, segment qr is parallel ef, and complete the following activity to prove segment PR parallel DF. Yes students, we have to prove that PR is parallel to DF. Okay students, so here this one is the PR and this one is the DF. They are parallel to each other. For that proof, we have to get the complete the activity. So here in triangle XDE. So here see students, XDE here XDE, that means here students, this one XDE. So this one triangle students, this one triangle. Okay, I show that here. Okay, this one triangle. Okay, and in this triangle students, see here, in this triangle PQ parallel DE. See here, PQ parallel DE. So here students, we can use the basic proportionality theorem. We know that the basic proportionality theorem, that is XP, here XP divided by PD. XP, here I write XP divided by PD is equal to XQ divided by QE. XQ here students, divided by XQ divided by QE. Okay, then this first part is completed. Now the second part, that is in triangle. In triangle, students see here, in triangle XEF. So where is that XEF students? See here that XEF students. Okay, X here, XEF. This one students. Okay, this. So in this triangle students, see here, this one, okay. So in this triangle, that QR, see here, QR is parallel to EF, QR is parallel to EF. So by using basic proportionality here students, we write here in this box, that is basic proportionality theorem. Basic proportionality theorem. Okay students, and then we get the proportional, that ratios of proportional, that is SQ divided by QE. See here, SQ divided by QE students, and then here SR divided by RF. So I write here XR. Okay, so now here call it as this one ratio as first one, second, this one as the second one ratio. So here from 1 and 2, from 1 and 2 students, see here that the XQ and QE, these ratios are equal, these ratios are equal. So that means these ratios would be equal. So here XP divided by PD is equal to students XR divided by RF. XR divided by RF. So see here in which triangle it is this ratio included. See here XP divided by PD is equal to XR divided by RF. So they included that, this ratio included in this triangle XDF students, XDF, and in the XDF, that means students the ratios are equal. Ratios are equal, that means students the sides are equal. See here PR and DF are parallel students, not equal, that are parallel. Okay, so here we say segment PR parallel segment DF, that is the converse of basic proportionality theorem. Okay student, then next one example student, see the next one example here. So next one example is about the circle and here we say that ABC are any point. See, ABC are any point on the circle with center O. Okay, with center O. If major arc ABC, see here, major arc this one BC, that is 110. Okay, students, see this portion, students. Major arc BC is equal to 110. Then major arc AB, students, see here, the major arc AB. So this major arc AB is equal to 125. 125 students. Complete the following activity. Find major arc ABC. We have to find out the total ABC. This one. Okay, major arc ABC. Then we have to find out major arc AC. This student, this arc. Then major arc ACB. This one, major arc ACB. Okay, and as well as students, major arc BAC. Okay, student. So here for that there is a activity. So here see that activity. That first one, major arc ABC, major arc ABC is equal to major arc AB. See here, major arc ABC. We have to find out this major arc ABC. So here we can say major arc AB plus major arc BC. So here I write major arc BC. Okay, students. Then here major arc AB is given. So that is 125 degree. And the major arc BC is also given, that is 110 degree. So here their addition is 235 students. Okay, 235 degree. Then next one, the first part is over. Then the second part, major arc AC. We have to calculate the major arc AC. How can we calculate major arc AC? That the whole major of the circle minus the major arc ABC. Major arc ABC. Now here students we calculate now the major arc ABC, and that is the 235. So in this box I write here major arc ABC as 235. So 360 minus 235, that is equal to 125. Okay student. So the second part is cover up. Now the third part students. That third part is major arc ACB. See here, major arc ACB here, from here students. Okay, ACB. So now here that 360 minus major arc that AB. So here, okay, major arc AB. So now here students, major arc here 360 and major arc AB, that is 125. So here student 360 minus 125, and that means students that is a 235 degree. Okay student. So the third part is covered. Then the fourth one part students, fourth one part. See the fourth one part, major arc BAC. See here students, we have to calculate the major arc BAC, this portion students. Major arc BAC, this portion. So how can we calculate that BAC? That is 360 minus major arc BC. Major arc BC. So I write here major arc BC. Okay, so now we have 360 minus major arc BC, that is a 110. So that means student 360 minus 110. So that means student the 250 degree. Okay, so the fourth one part is also covered up students. Okay, such a way we can solve this activity which is based on the circle. Okay, so now here next one question, and that next one question is for the B question, B sub question. So here students we have to solve the following sub question, and there are the 3 questions, and we have to solve only any 2 students. Okay students, and each having the 3 marks. So let us see the next one question students, and that next one question says that the radius of a circle is 6 meter. The area of a sector of this circle is 15 pi square centimeter. Find the measure of the arc and the length of the arc corresponding that sector. Okay, students. Now here, students, here the radius. Okay, first we write down the given, and in the given I write down that radius of circle. Radius of circle, so that r is equal to 6 centimeter. Then area of sector, so here area of sector A is equal to 15 pi. Okay, and then here find measure of arc. Measure of arc. So that means here students will have to calculate theta and here length of arc. Length of arc. And that is L is equal to question mark. Okay students. So now here students, we know that we have to calculate the length of arc. We know that here first I write down the formula, and that formula for the area of sector. See here. First area of sector. Area of sector. So now here, if I want to calculate the theta, then I can use here the area of sector formula, and that is theta upon 360 multiply pi r square. Okay students, so now here students, area of sector, and that is equal to 15 pi, which is equal to students, which is equal to theta upon 360 multiply here pi multiply r. So now here students, the radius is that square of 6. Okay. So here students, pi get cancelled, and then 15 is equal to theta upon 360, and here multiply, that is square of 6, that is a 36. So here 15 multiply 360 divided by students 36, which is equal to theta. Okay, so now here students, that 36 ones are 36, 36 tens are. So 15 multiply 10, which is equal to theta. So here 150 is equal to theta. So theta is equal to 150 degree. Okay students, theta is equal to 150 degree. Okay, so now here, is it visible or not students? Yes, here I write here that portion. 150 is equal to theta, so theta is equal to 150 degree. Okay students, theta is equal to 150 degree. So now here that we have to calculate the L students. We have to calculate the L. So now here that the formula for area of sector and the relation between the area of sector and the length of arc, there is a formula, and that formula is students, that area of sector is equal to LR upon 2. And so here students, here students, by this formula area of sector, so area of sector is 15 pi. Okay, length write down as it is, then 6 and divided by 2. So here 15 pi multiply 2 divided by 6 is equal to L. So here 2 ones are 2 3s are 6, 3 ones are 3 5s are. So student 5 pi L. So here length of arc is equal to 5 pi. Okay, and here the centimeter. Calculate in centimeter. Okay student, so such a way, by using the area of sector, that the different formula here, this one is the first one formula, this one is the another one formula for the area of the sector, and that can we calculate the length of the arc and as well as the measure of the arc, students. Okay, so now let us see the next one question, students. See here the next one question, and that next one question is that if A35 and B79 point Q divides segment AB in the ratio 2:3, find the coordinates of point Q. Okay, students, we have to find out the coordinate of the point Q. So now here, students, there are the 2 points. There are the 2 points. So first I write down in the given A 3 5, then here B 7 9, and then here that I write point Q divides segment AB in the ratio 2:3. Okay, and here coordinates of point Q. Coordinates of point Q is equal to question mark. Okay, students. Now here, students, we have to calculate coordinates of the point Q, and there is a line segment is given, and here that line segment, and in that line segment there is a point Q, and which divides the line segment by 2:3. So that means here we use here the section formula. So here first I write down A35, which is equal to A x1 y1. So here x1 is equal to 3, y1 is equal to 5. Then here, students, that the second point B79, so which is equal to B x2 y2, and that means, students, here that x2 is equal to 7, y2 is equal to 9. Okay, and here as well as, students, given is that point Q divides segment AB in the ratio 2:3, means n is to n. Okay, students, and then I write down that by using section formula. Okay, by using section formula. So section formula, what is the section formula? That is coordinates of point Q. Coordinates of point Q is equal to nx2 plus nx1 divided by n plus n, comma my2 plus ny1 upon n plus n. So now here, students, that is fill up the or substitute these given values. So here mx2, so that means here n means the 2, so here 2 multiply 7 plus 3 multiply 3 divided by 2 plus 3, comma here 2 multiply that y2 is 9, 2 multiply 9 plus 3 multiply 5, 2 plus 3, bracket complete. So now here we solve this. So 7 2s are 14 plus 3 3s are 9 upon 5, and here 18 2 9s are 18 plus 3 5s are 15. So 18 plus 15 upon 5. So here 14 plus 9, that means 23 upon 5, and here 18 plus 15 23 33 upon 5. Okay, so here we say that therefore coordinates coordinates of point Q. Coordinates of point Q is equal to 23 upon 5 and 33 upon 5. Okay, students? Then next one example, students. See the next one example. Okay? That the question 3, for prove that in a right angle triangle the square of hypotenuse is equal to the sum of the square of remaining two sides. Okay, student. So here, students, this is the Pythagoras theorem. Okay, student, this is the Pythagoras theorem. So this is the statement of the Pythagoras theorem. Very easy, student. So first we write down. Okay. First we write down the statement, student. First write down the statement, then you can get the half mark. So here statements, and there is nothing worry about that you have to write down as it is. This is the statement of the Pythagoras. So write down as it is statement. Then in a right angle triangle, right angle triangle, the square of the hypotenuse is equal to the square of the remaining two sides. Remaining two sides. Okay, student, this is the statement. Now here, after statement, we draw the figure. Okay, student. So first here we draw the figure, and this is the figure. Okay, I write down here figure. Then here, as per information, in a right angle triangle. So I draw the right angle triangle. Okay, I draw the right angle triangle. So this is right angle triangle and name it as ABC. Okay. So this is a figure bus. Okay. And here that given. Then write down the given. Next part given. So as per given drawing figure, we have to write the given. So by seeing the figure, write down given. Triangle ABC is a right angle triangle. Is a right angle triangle. Then major angle ABC is equal to 90 degree. Okay, and here you can also see write down that segment AB and segment BC are the right angle sides. Are the right angle sides, and as well as students, you can write down AC is the hypotenuse. Okay, segment AC is a hypotenuse. Okay, so this information that we write down by the figure. Then here, students, then next one, that is write down given, then to prove. Then the turn of to prove. Okay, students. Then here to prove in a right angle triangle the square of the hypotenuse. Here square of AC is equal to, that is the sum of the square is equal to the sum of squares. So here is equal to sum of squares of remaining two sides. So remaining two sides are AB, square of AB and the square of BC. So that we have to put down. Okay student. So now here students that there is a only triangle students, and here it is only the right angle triangle, and there beyond that we don't know. So there is a need of construction. We should have to draw any construction. Okay, so which one is that construction that take any point D on the hypotenuse? So such that I write down that BD perpendicular AC. Okay, draw BD perpendicular AC. So this one is the construction. Draw BD perpendicular hypotenuse AC. Okay, so now here students, as we draw the perpendicular, then we get the three right angle triangle, and that right angle triangles are ABC. See here, ABC, then here BDC, okay, and then here students that is BDA. Okay, so these are the right angle triangles students. Okay, and that means here students, by the similarity of the right angle triangles, these triangles are similar. Okay students, so that means here students, in the proof we start from this, that triangle ABC similar to triangle BDA, similar to triangle BDC. So here students, because of the construction, so here I say that segment BD perpendicular segment AC, and then we can say that triangle ABC similar to triangle BDA similar to triangle BDC. Okay students, so one by one we take the pair of the triangle. So here that the first part, that triangle ABC similar to triangle BDC. So that means here the corresponding side ratios are equal. So here we say AB upon BD is equal to BC upon DC, which is equal to AC upon BD. Okay students, so now here students, that here BDC. Yes students, here let's see which one we have to take that. No one is BDA. There is a mistake from A, B, C. So here students, A is congruent to C. So CDB. Okay, here we write that CDB. CDB. So here students, that CD, AB upon CD, okay, then BC upon DB, okay, and then AC upon students, AC upon BC, yes, okay students, and then we take these two ratios, BC upon DB is equal to AC upon BC. So here BC multiply BC is equal to DB multiply AC. So here students, BC square is equal to DB multiply AC. So here we can call it as the first one equation. Okay, and then the next part that students is that taking the two triangles, similar triangle. So triangle ABC similar to triangle here BDC, BDA here. Okay, so here AB upon BD, which is equal to BC upon DA, is equal to students AC upon BA. So now here students we take the first one and the third one ratio. AB upon BD is equal to AC upon BA. Why we take this? Because the cross multiply. We get the square of the sides. Okay, so BA, I write down BA as AB. So AB multiply AB equal to BD multiply AC. Okay, student. So here AB square is equal to BD multiply AC. Okay, so now here call it as the second one equation. Call it as the second one equation. Okay, so now here students I write here the remaining part. Okay, so that remaining part is that here adding equation 1 and 2. Adding equations 1 and 2. So here BC square plus AB square is equal to students dB multiply AC. dB multiply AC plus here BD multiply AC. BD both are the BD students. Okay, so I think here there is a mistake, some mistake arising here. BDA, BDA and BDC. Okay, so here students that I think there is some mistake that BD into AC. DA students, this part. Okay, that. See here first I write down that AC is the common. Okay, AC is the common and they students that AD plus DC. We want the AD plus DC students. Not here that dB and dB. So here dB and dB that means the altitude students. Okay, so there is some mistake arisen. So here we take that ADB. Okay, ABC. Then here students ADB. Okay, ADB. Yes, here ADB. Okay, students see here. I write down that here AB upon AD is equal to BC upon DB is equal to AC upon AB. Okay, students, taking these two ratios, so AB upon AD is equal to AC upon AB. So here AB multiply AB is equal to AD multiply AC. Okay, students, so AB square is equal to AD multiply AC and then call it as second one. And here also some mistake. I think there is some mistake that here ABC and BDC. ABC and BDC students. Okay. So here students AB upon BD is equal to BC upon DC is equal to AC upon BC. Okay, so now taking this ratio BC upon DC is equal to AC upon BC. So here BC multiply BC is equal to DC multiply AC. Yes, students. So now this is called as loop. The next one is that is square of DC is equal to DC multiply AC and then call it as the second one equation. Okay, so then adding equation 1 and 2. Then the this one is first one here students that DC into AC. So here I write down DC multiply AC and the second one AD multiply AC. AD multiply AC. So now here student AC and AC get common and then in the bracket DC plus AD. Okay. So see here DC plus AD and that means nothing but the AC. So here AC into AC, and that means students AC square. So here we say that BC square plus AB square is equal to AC square. Finally, we write down AB square plus BC square is equal to AC square. Hence, proved. Okay. Hence, Pythagoras theorem proved. Okay, students? Such a way we can write down the theorem. Okay. Then next one example, students. Then the next one example, and that next one example is for I think it is a construction student. So for the construction there is a special video, you see that video. Okay. Then next one example, students. Next one example is from the question 4. Solve the following sub question, and we have to solve any two. Okay. So now here the first one question, students. What is the first one question? So here that's given, sorry, a bucket is in the form of a frustum of a cone. It holds 28.4990 liters of water. The radii of the top of the bottom are 28 centimeter, 21 centimeter respectively. Find the height of the bucket and taken as pi as a 22/7. So now here given is a frustum of a cone, students. So in the given I write down that frustum of a cone. Frustum of a cone. Okay, students, and then students, then here students, yes, it is audible. Hello, hello, yes, okay. Then here students, that frustum of a cone, and then I write down that it holds 28.490 liters of water. That means it is a volume, okay, volume of a frustum. So I write down that volume V is equal to 28.490 liter. Okay, students. Now here, if you observe, the given radii are in centimeters. So we convert this volume that in the liter, which is are in liter, that convert in centimeter. So that means here I multiply this 28.490 multiplied by 1000. Okay, then it will be convert in the centimeter cube. So here 28,490 divided by 1000. Here multiply 1000 and then 1000 get cancelled and we get 28,490 cubic centimeter. Okay, students, so volume becomes this one. Then next one, that is the radii of the top. So I write down radii of the top, radius of the top, radius of the top, and that radius of the top mentioned by R1, and that is equal to 28 centimeter. Then radius of the bottom, radius of the bottom R2 is equal to 21 centimeter. Okay, students, and we have to also there is a pi, that pi is equal to 22/7, and then lastly I write down height of the bucket. Okay, height of the bucket. So now here students, height of the bucket, it is the example of the frustum of a cone. It is the example of the frustum of a cone. So now here students, if you know the formula for the frustum of a cone, then you can easily solve this example. But if you don't know this formula, then you can't solve it. So first we write down that formula, and that formula is say that volume V is equal to 1/3 pi in the bracket R1 square plus R1 square plus R2 square plus R1, R2 and multiply H. Okay, this is the formula of volume of a frustum. So now here substitution students, volume is given, that is 28,490, 1 upon 3 multiply 22 upon 7 multiply square of 28 plus square of 21 plus 28 multiply 21, then multiply H. Okay. Then here first I do the square of these and then addition of these. So 22 upon 7 multiply here. So here square of 28, that means here students, the square of 28, that is 784. And the square of 21, that is 441. And the students, 28 multiply 21. 588. Okay students, here 588 multiply H. Okay, so now here students, this is 28490, then here 28490 is equal to 22 upon 3 multiply 7, then here addition of these 784, 441 and 588. Then here 1813. 1813 multiply H. Okay students, so simplify here 28490 multiply 3 multiply 7 divided by 22 multiply 1813, which is equal to H. Okay students, so now your students see that 7 and 1813. So 1813 divided by 7, then 7 2s are 14, 4 is 35, then 6, 3, 7 9s are 16. Yes, students. So here 7 1s are 7 and here 259. Okay. Then here students, then next one, that is the 259 and 28490. But I here write down like 22 that divided by 28490. 28490 divided by 22. So 22 ones are 22. Here 6 4 2s are 44. So here 0 2 and then 9. Then here 20 9s are, okay, 29s are 198, then 1, then here 1 0, so 110, so 19, 22 5s are 110, so here 21 ones are 21 and here 1295. Okay students, this way. And then here students 259 and 1295. Is there correlation? 259. 259 multiply 5, that means 45. 1295. Yes. 259 ones are 259 and 1295. Okay. So now here 5 multiply 3. 5 multiply 3 is equal to H. That means students 15 is equal to H. So here H is equal to 15 centimeter. Okay students. So finally we write down the answer, the statement, and the statement is that students, the height of the bucket. Therefore the height of the bucket, is equal to 15 centimeter. Okay students, this is the final answer. Okay. Then here students, you should have to solve with me such a type of the examples, because some examples are very new for you, and so they are not repeated in the PYQ. So you should have to practice with me and you should have to solve with me. Okay students, then you can practice. Then now here students, draw a circle with center P and radius 3 centimeter. Draw a chord MN of length 4 centimeter. Draw tangents to the circle through points N and N which intersect in point Q. Measure the length of the segment PQ. It is for construction, so you observe the video for the construction. Then here students, see here in triangle PQR, bisector of angle Q and R intersect in point X, line PX intersect side QR in point Y. Then prove that PQ plus PR upon QR is equal to PX upon XY. So now here students, first here it is the theorem students, we have to prove that. So here student, first I write down the, first I draw the figure, by the given information student. So here in triangle PQR, so I write down students that PQR, okay, P Q R. Okay, so now bisector of QR and R intersect in point Q. Okay, so now here bisector of Q and then bisector of R. Okay, so this is the bisector of R that intersect in the point X. Okay, so this is the point X. This is the point X. So line PX intersect. So this one line. So first I draw here. See this one line students. Line PX here intersect side QR in point Y. Okay, here also in point Y. So here students, first here students, I draw that the figure and the bisector here, that then here, yes, this way. Yes students. So now I write the P Q R. This is the angle bisector. Then here angle bisector and at intersect at X. And here is the point Y. Okay. Okay. So this is the figure as per the given information students. Then here students, then here I write down the given. So given in triangle PQR, here I write down that XY, here S and T. Okay, I write down the name. So here I say that so here QS, segment QS is the angle bisector of angle PQR, and here RT, segment RT is the angle bisector, the angle bisector of angle PRQ. PRQ. Okay, students. Then here QS and RT, segment QS and RT intersect at X. Okay, intersect at X. Then here, then line PX intersect side QR in point Y. In point Y. Okay, students. So now here, students, the given is written. Then here to prove, write down to prove. So to prove is that PQ plus QR upon QR is equal to Px upon xy. Okay, and then here, students, then write down the proof. Okay, then write down the proof. Okay, students. Then here proof. I forgot which term is after that to prove. Okay, so proof. Then here first one I write down that here the ray QS the is the angle bisector of angle PQR. Angle PQR. Therefore, here we can use the angle bisector theorem. So here by using the property of angle bisector, then we can say, students, that is PQ upon QR. PQ upon QR is equal to PS upon SR. PS upon SR. Call it as first one. Then the second part, students, that segment RT is the, or we say ray RT is the angle bisector of angle. I write down that ray RT. Okay, is the angle bisector of angle PRQ. Angle PRQ. Okay, and therefore by using the property of angle bisector, okay, we say that PR upon RQ is equal to, students, PT upon TQ. So now I call it as the second one. So now here, students, see that here nothing is that similar to each other. So now here, students, so I from 1 and 2 I added these from 1 and 2. Okay, or we say that adding okay, first I write down from 1 and 2 that PQ upon QR is equal to PS upon SR. Okay, and which is equal to PT upon TQ. Okay, students. So now here, students, as well as here PR upon RQ. PR upon RQ, or we say QR. Okay, so now here taking students, we take the two ratios, that is say here QR and here QR. So PQ plus PR. So here we take that by equal ratios property, we say that PQ plus PR upon QR is equal to students that Px upon xy. Okay, Px upon xy. So here students, that instead of Ps upon Sr, we can write down the Px upon xy. So here Px upon xy. Okay students, here. So now here students, this way. Here students, we can write down Px on Px. Yes students, here we write down that here such a way. Here students, X. Okay. Then Px upon Rx. Yes, here. Px instead of x, taking x, you can take students that x. Okay. And here that the PT, and here as well as here students, we can say that here C, that QP upon PR, that means QY upon YR, but it's not mentioned here. Okay, so that here we here write down PX upon XR. Here also XR. Okay, students, and then here we write that XR and that nothing but the XY. So here we say that PX upon XY. Okay, that the similar ratios. Okay, students, that is PQ plus PR, PQ plus PR, QR, and that QR means QY upon YR, and that is equal to PX upon XY. Okay, student? So such a way we can uh, prove this theorem. Okay, students? Yes. Then next one, students. Here, next one is that students, the question 5, solve the following sub question. Anyone, we have to solve anyone here. Okay, see the first one question. Then from the top of the building, Ramesh is looking at a bicycle parked at some distance away from the building on the roof. If AB height of the building is 40 meter, C that is the position of bicycle, A that is the position of Ramesh on the top of the building, angle MAC is the angle of depression and major angle MAC is equal to 30 degree, then draw a figure with the given information. And then we find the distance between the building and the bicycle, that is root 3 is equal to 1.73. Okay students, so now here students, that first I draw the figure as per the given information. Okay, so the given information, first I write down, first I draw the ground level. Okay, first I draw the ground level, then there is a bicycle, that bicycle C here. Okay, then here height of the building, position of the bicycle. A is the position of Ramesh on the top of the building. So here height of the building, okay, AB. So this H, that means I write down height of the building. Here we write down building only. Okay, and at the top of the building, that there is a position of Ramesh. So this position, at the A position, Ramesh is here. Okay, and then here, top of the building, angle MAC. MAC is the angle of depression. So here students, MAC, this way. Okay, MAC. So here this way, MAC is, and that angle MAC is the 30 degree. Okay, students, 30 degree. This way. Then here that this angle will be 90 degree, student. So automatically this angle will be 60 degree. Okay, and here angle MAC is equal to 30 degree. So this angle becomes 30 degree. Okay, students. So this way we can draw the figure. So the first part, that A part is completed. Okay, bicycle. Okay, here student giving that is equal to, here H is equal to 40 meter. That is necessary part that you have to write down. But okay, so that much enough. Then the next, find the distance between the building and the bicycle. That we have to calculate the BC. So the BC is equal to question mark. Okay, so now here, so first I write down BC, that is the distance between building and the bicycle is equal to question mark. Okay, students. Then here next one, BC. Here we have to calculate BC. We know the H, so that means the opposite side and the adjacent side. So that mentioned in the tan ratio. So here we write down tan 60. Here we write down tan 60 is equal to AB, this one AB upon BC. Okay, students, and we know that tan 60 and tan 60 is equal to root 3, and AB is the 40 height of the building, and BC. So here BC is equal to 40 divided by root 3. Okay, students. Sorry, students. BC upon AB here, students. BC upon AB. So here BC upon 40. So here student, BC is equal to 40 root 3. So here BC is equal to 40 multiply root 3, that is 1.73. And so student, BC is equal to, so here 0, 69.20 meter. Okay, 69.20 meter. Okay, so here I write down the final answer. Distance between building and bicycle, that is equal to 69.20 meter. Okay, student, such a way we can write down. Okay. Then here, students, the next one example. That next one example is quadrilateral ABCD is a cyclic quadrilateral where side AB congruent to side BC, angle ADC is equal to 110, BC is the diagonal. Then first draw the figure by using the given information. Yes, student. So here first I draw the figure. So here there is a circle, and in that circle A, B, C, D. Okay. So I here A, draw the quadrilateral. So here name it A, B, C, D. Okay, so here AB congruent to BC. So AB congruent to BC. Okay, then ADC. See here ADC, that is equal to 110. Okay, AC is the diagonal. Yes, AC is the diagonal. Yes. So now here this information, by the given information, we draw this figure. Okay. Then student, the B part, find the measure of angle ABC. Okay. Angle ABC. Angle ABC is the opposite angle of angle ADC. So here we say that uh, opposite angles, opposite angles in a cyclic quadrilateral, in a cyclic quadrilateral are supplementary, are supplementary. So now here supplementary means students, their addition is 180 degrees. So angle ADC plus angle ABC is equal to 180 degree. Okay student, so ADC is 110 degree plus angle ABC is equal to 180. So here angle ABC is equal to 180 minus 110. So here students, angle ABC is equal to 70 degree. Okay. Then the first part is over, angle ABC is equal to 70 degree. Okay students, and then students, the next one part, that is the C part students. Find major angle BAC, BAC, no, BAC, this one students, this angle, we have to calculate this angle. So now here student, ABC is a isosceles triangle, okay, triangle ABC is an isosceles triangle, therefore by using some angle property, okay, we have students angle A BC plus angle BCA plus angle CAB is equal to 180 degree. Okay, and now here students, these sides are equal, so that means BAC is equal to angle BCA. So instead of I write BCA, I write BAC. So here BAC, yes, here is the BAC. Okay, so here I write down here also BAC, angle CAB, that means CAB students, okay, and the ABC, that angle is ABC is 70, so 70, which is equal to 180 degree. So now here, so now 2 times this, 2 angle CAB is equal to 180 minus 70, so 2 angle CAB is equal to 110. So angle CAB is equal to 110 upon 2, that is 55 degree. Okay students, 55 degree. Then the C part is over. Now the D part, find measure of arc ABC. Arc ABC students. Okay. So arc ABC, so that means here students, here D part, that is angle ADC is equal to 1 upon 2 major arc ABC. Okay students, that is the inscribed angle theorem. So ADC, here students, ADC is 110, so I write 110 is equal to 2 and then major arc ABC. Then here students, 110 multiply 2 which is equal to major arc ABC. So here 220 degree is equal to major arc ABC. So here students we write major arc ABC is equal to 220 degree. Okay student. So all these ABCD parts are over. So that means here students we can stepwise you can calculate the given example or we solve it the given example as per the given information. So here such a way we complete this uh, students. Yes, we completed these students uh, previous year board question paper July 2023 students here, and here students that see here this you practice this such a type of the PYQ. Okay, so if you like our content, then students do not forget to subscribe our channel. So subscribe our channel if you like our content. So best of luck for your coming SSC board exam.